Today we're going to take a look at section 9.3, which is about solving exponential equations. So there are three primary methods for solving. Today we're going to focus on two, and then another lesson we will focus on the third. So the first method, method number one, is a method referred to as same base, which means that we're going to be able to take both sides of the equation and rewrite them so that they have the same base, and then we can apply a property of equality that we're going to talk about in a moment to solve the equation. Okay? The second method is to use a graphing calculator. And we'll have two ways to do that. We can either use the zero method, which we've discussed before, or we can use the intersect method, which we have also discussed before. Okay? So this is what we're going to be working on today, these two methods. The third method is by using what are called logarithms. And this is what we'll be looking at later in the chapter, how to solve using logarithms. So this is coming up later. This is not today. All right? Okay. So let's take a look at what that property of equality is. So the property of equality for exponential functions states that if b is a positive number other than 1, then if you have b to the x1 is equal to b to the x2, that will only be true if and only if x1 is equal to x2. All right? So it's saying if you have two different exponentials with the same base set equal to each other, their exponents must also be equal. So how does this help us? If we can make the bases match, then we can set the exponents equal to one another. And that will allow us to solve the equation. Okay. So this is what we're going to be focusing on. If we can get it to have this set up here where we have the bases are the same, we will then set the exponents equal to one another and solve for x. So we're going to go through 4 different examples of how to do the same base method, and then we'll take a look at one example with the 2 different methods on a graphing calculator. Okay. Problem number 1. 4 to the x power is equal to 1 over 64. Okay, so I want to see if I can rewrite the 1 over 64 so that it's 4 to a power. All right, so the first thing I'm going to do is leave that 4 to the x alone, but I need to think about how can I rewrite 64 so that it's 4 to a power. So think for a second. 4 to what power is 64? I bet you guys have come up with 4 to the third power is equal to 64. All right. But I've got 4 to the x and I've got 1 over 4 to the third. So the next step is we need to apply the rule for negative exponents. 4 to the x. If I have 1 over 4 to the third, that's the same thing as 4 to the negative third. So a little sidebar, I want to remind you that if we have something like x to the negative 2 power, that's 1 over x to the positive 2 power. So we're used to going in this direction, but now what we're going to do is we're going to start here and we're working back this way. We're reintroducing the negative exponent, okay? So that's what I'm doing going from here to here. I'm just applying that negative exponent rule in reverse. And now I have one base and another base that are identical, which means the exponents must be equal to one another. So that means the solution to this equation is x equals negative 3. Right. That one's one of our more basic ones. Let's take a look at a little bit more challenging problem. Okay. Problem number 2. We have 81 is equal to 27 to the m minus 1 power. Now, I don't know how to make an 81 and a 27 match, so I need to change both of the bases in this case. So we want to think about, well, what's the smallest base we can possibly come up with? So 81 could be 9 squared, But I can't write 27 as 9 to an exponent. That doesn't really work out. So 9's not our best choice. So let's go even smaller. 81 and 27 are both perfect powers of 3. So 81 is 3 to the 4th power, and 27 is 3 to the 3rd power. So I'm replacing the 81 with a 3 to the 4th. I'm replacing the 27 with 3 to the 3rd. And now rules of exponents tell us that we can actually distribute this 3 to those. I can do power to a power. I can multiply these two exponents together. So now we're going to have 3 to the 4th power is equal to 3 to the 3m minus 3. Okay, so I'm multiplying the exponent 3 by the m minus 1. Now I have the same base right here, same base, they're both base 3. The exponents must be equal to one another in order for this statement to be true, applying that property of equality. And now I have a basic linear equation to solve. Add the 3 to both sides to get 7 equals 3m. Divide out the 3 and you get m equals 7/3. So the answer, the solution to this equation is just m equals 7/3. All right, I'm going to make separate videos for the other examples because they are a little bit longer, but this is your basic introduction to how to solve exponential equations.